Hi there, and welcome to your physics projectile quiz review. We did all this in class today, but I want to make sure you just have a little resource if you choose to kind of study a little more for tomorrow's quiz. So here we go. We talked about vectors in two dimension. This was from our textbook stuff, really looking at how vectors here in the horizontal have a constant velocity. The velocity is there, but they have an acceleration of 0, and we can see the velocity is constant as it goes through there. But in the vertical component, we can see the velocity here is always changing from small and then increasing as it goes down. So we have a changing velocity when it comes to the vertical, but the acceleration in the vertical direction is always equal to the gravity, negative 9.8 meters per second squared. And the result of all those things by having a difference in our vertical velocities and our horizontal is that you end up with these types of vectors, which create that parabolic shape which gives it that nice curve. And that was kind of the overall thing we talked about. With all the lesson here, just keep in mind that projectiles are things that are launched, they're up in the air. Either they're launched up or they're falling off, but they have to be in the air. So if you're just rolling a ball or going down a slide or something, that is not a projectile, that's movement. But projectile means it's getting out into the air and open and up. So throwing a ball is a projectile, frisbee projectile. So different formulas. Here's one we talked about just for the parabolic trajectory. So if we're looking at something launched at an angle, it's not just falling down, but now it's being launched and it goes that way. And we have the nice symmetry here because of the way it works with our vertical motion velocity going up and down, that you tend to have the symmetry happening as you look at those different vectors, which is kind of cool. All right, so we have all these formulas here, which again will be up on the board for you as we go along. And so let's take a look at some review. We said that horizontal and vertical motion are independent, so they happen. This one's going to be going up and down and does not affect how the side to side goes. So they're independent actions there. When it comes to how when an object is launched, whether it be from a horizontal kind of rolling off a cliff or being launched this way, that horizontal velocity is constant and acceleration is always going to be 0. So that means our horizontal is in the same vectors, the same way all the way through, and it's not accelerating. It's just going to be 0. And it's not getting any faster unless you were to put like a little jetpack on here and then make it start like launching off because acceleration is 0. But in terms of the vertical, the velocity is always changing as it tends to increase as you go further because gravity is acting upon it, causing some sort of acceleration to occur. All right, so that's that part. And then we talked about our formula for the AY. AY is one of those terms we're going to use a lot when it comes to using our formulas, and AY is equal to gravity. So use negative 9.8 for your calculations there. In terms of the path of projectile, that curved path is a parabola. So it's a parabolic path, right? That is how that works when you're talking about projectile, whether it be going up and over or if it's falling off the cliff, it's still a parabola because it's curving downwards. And then finally, as we said before, it's a combination of two types of motion, horizontal and vertical. So those are the important things to remember when you go there. So you'll have some regular multiple choice questions and just kind of keep in mind, what are we talking about? How do projectiles work? How do they move? Now let's move over into that's funny. Move over into the practice problems here. So here we have, first of all, an arrow is launched with an initial velocity of 15 meters per second at an angle of 40 degrees relative to the horizon. If it travels for 2 seconds, what's the horizontal displacement? So we have it going at 15 meters per second. We have a theta of 40 and degrees, and we actually have a time this time of 2 seconds. So in terms of what I'm given, this is the information that I'm given here. And so that's what I have. I can now decide my horizontal displacement, and the formula for that is horizontal displacement delta x equals VI, or initial velocity, times the cosine of theta times the change in time. And so in this case here, our initial velocity is 15, and we're going to multiply that by cosine of 40, and then we're going to multiply that by 2. And so when we put that into our calculator, again, it's important to know how to use your calculator. Um, and times 2, I end up with 22.98. And if I was to round that to a nearest tenth, I'd actually end up with a whole number of 23. And we're looking at maybe meters, so be meters. And what we're saying is that from here to here, this distance traveled from wherever it was going to be is 23 meters for how far it's going to go. All right, and that's what displacement is, how much movement it moves from where it started to where it ended. Our next one. Matthew kicks a soccer ball with an initial velocity of 15 meters per second at an angle of 35 degrees relative to the ground. What are the horizontal and vertical components? When we're doing components, we're talking about the other parts here. The horizontal component is here, and the vertical component is here to create this resultant vector there. So for the horizontal one, the horizontal formula is when we're looking at this measurement. Well, this is our hypotenuse, which makes, because this is our angle here, this is our adjacent, and this is our opposite. And so as a result, we want to look for the adjacent. So we're going to look for the cosine of theta. And in our case here, we don't just leave it as cosine, we do the VI times cosine of theta. And that's all we're going to do there. So our VI in this case is 15. Our cosine is cosine 35. So we do 15 times cosine 35, and we end up with 12.287. And if I go to the nearest tenth, that would be 12.3 for the nearest tenth there. My vertical component here, maybe I'll make it green here, vertical component, we're going to do the VI times the sine of theta. And it's a sine because sine is opposite over hypotenuse. So 15 times the sine of 35. Clear my calculator, 15 times sine of 35 is equal to 8.60. And of course, the nearest tenth would just be simply 8.6. So those are the ones for the component, all right? That's my component. So up here, we had not just the component, but we also multiplied by time in order to get the displacement. All right, and now this was the component one. Let's take a look at the ball. Here we have the ball pushed off a table that is 8 meters tall. If the ball lands a distance 3.5 meters from the edge of the table, what's the initial velocity? So the ball is going this way down there. We have it being 8 meters tall, and we have 3.5 for X marks the spot. So elements that we do know. We know our change in y is going to be the difference from 0 minus where it started to 8. So 0 minus 8 is a negative 8. Our change in x is what's given here. So 3.5 minus 0 is simply 3.5. We know the value of a of y, or gravity, as negative 9.8 meters per second. We do not know the initial velocity. That's what we're trying to find out. But we also talked about the fact that in order to find the initial velocity, I'm going to need to know how long that was in the air, which I do not know. So the first thing is I need to find out the time. The time is going to be equal to the square root of 2 times nope, sorry, 2 times, sorry, where's my eraser at? 2 times, there we go. There we go, perfect. So 2 times delta y over a sub y. Now in this case here, this is going to be the square root of 2 times negative 8 divided by negative 9.8, which becomes the square root of square root of negative 16 divided by negative 9.8. So 16 divided by 9.8, and I can not worry about the negatives because a negative divided by negative is a positive, gives me the square root of 1.6326. I just write down about 4 decimals there, and so I'm going to type in on my calculator here the square root of 1.6326 and equals 1.277. Or if I wanted to estimate that, I could say maybe 1.3. I'm going to keep it at 1.27. I think it actually does 2.77. Just because I like to have a few more numbers after the decimal to make sure that I am not rounding too early, because it will affect your end result. So that's my t of 1.277 seconds. And now I can go up into my formula for the x. We said that x equals v of x times delta t. That's our formula for one of the things we had. So that's solving for x. Now I already know the x and I know the t, but I want to get the v of x by itself. So I divide both sides by delta t, so that v of x equals delta t, v of x equals delta x divided by delta t. So I'm going to do 3.5 divided by 1.277. So 3.5 divided by 1.277 is going to equal, in this case here, 2.74 meters per second is how fast the ball was traveling in order for that to all work. So 2.74. If I did the nearest 10th, I'd have 2.7, and that's it. Okay, so that's one example there. Again, starting with finding the t and then finding the velocity. So we have another one here, same idea. Ball pushed off a cliff once again. These balls keep falling off of cliffs. We have 24 meters is our height, how tall it is, and it falls 10 meters away for X marks the spot. We do not know our initial velocity. We do not know our time. We know our change in y is negative 24. We know our change of x is 10. And we know our a of y equals negative 9.8. So once again, I need to find the time. Time is going to be the square root of 2 times the change in y divided by a sub y, or in this case here, square root of 2 times negative 24 divided by negative 9.8. So this becomes a square root of negative 48 divided by negative 9.8. And 48 divided by 9.8 is going to be equal to the square root of 4.8979. And then I will take the square root of 4.8979 and end up with 2.213 for my time element. So time is 2.213, which is great, but I'm trying to solve for my velocity. And again, x is equal to velocity times time. So velocity is actually equal to x divided by time. So we're going to do 10 divided by 2.213. And 10 divided by 2.213 is equal to velocity equals 4.518 meters per second. And if I had to do the nearest 10th, it would just be 4.5 meters per second for the velocity for into meters per second. Okay, so that's that one there. All right, cannonball. We did not do this one in the class. Is launched with a velocity of 30 meters per second at an angle 15 degrees relative to horizon. What are the approximate horizontal and vertical components? So once again, this is the easier one. We're doing horizontal and vertical component. And again, this is the horizontal component. And I could say this is the vertical component. And that makes this my hypotenuse, which makes this my adjacent and makes this my opposite. And so for my components here, we're going to say that for the horizontal, it's going to be VI times, with the adjacent, cosine of theta. And for my vertical, it's going to be VI times the sine of theta. So we end up with 30 times cosine 15. And then here we have 30 times sine of 15. And then we do some math times cosine 15. And this one ends up being 28.977. Again, if I did the nearest tenth, that's going to round up actually to 29.0. And over here, we have 30 times the sine of 15, which equals 7.764. So if I did the nearest tenth there, I would do 7.8 for the nearest tenth, rounding it there to the next number. Okay, so those are the horizontal and vertical components for that one. And our last one here, pencil falls off the table, 2.4 meters tall, lands 0.65 meters away from the edge. What's my initial velocity? So same as before, initial velocity question. So hopefully you're getting the idea that this is going to be a question on your test. I don't know velocity, I don't know time. I know the change in y is negative 2.4, change of x is 0.65, and my a of y is negative 9.8. And so hopefully you've seen that every single one of these problems, I have rewritten the same variables. What do I know? I'm drawing a picture and then I write down the equation. So first, got to find out time, square root of 2 times delta y divided by ay. So this becomes the square root of 2 times delta y, negative 2.4, divided by negative 9.8. So 2.4 times 2 is going to be negative 4.8 divided by negative 9.8, square root of all that. So 4.8 divided by 9.8, again, I can make it positive because a negative divided by negative is a positive, is going to be the square root of 0.4897. I can just keep those numbers there and do the square root of 0.4897. And I end up with 0.6997 for time. I'm going to leave it like that because it's a big number. If I was to round that, I'd end up with 0.70, which you could do. I'm going to keep it like that because I'm just using it for the next part of the problem. Again, next part of the problem is delta x equals velocity times the change in time, or velocity equals x over time. And so our x change is 0.65 divided by 0.6997. So do the math there. 0.65 divided by 0.6997 gives me a grand total for velocity equals 0.9289. And if I had to do the nearest tenth, I would actually say it's 1. And nearest hundredth would be 9.3 or 0.93. That's the nearest hundredth. And I guess if I had to do, sorry, if the nearest tenth, it would just be 0.9 for the nearest tenth if I had to keep rounding there. All right, that's it. Hopefully that gives you some information on the types of questions you'll see. And good luck. Again, open notes, you'll do just fine. We will see you tomorrow.